Hi and welcome. In this video we're going to cover how to add a circular pattern using diamond grids in LunchBox onto a model. This video is intended for RMIT industrial design students, but if that's not you, welcome, and we hope that you take something out of the video. So without further ado, let's get modeling. Okay. What we've got here is in class we did something different. We did this little form with these hole perforations. If you look at my little camera view down here, effectively we've got the same kind of shape. We've got a revolve. The revolve is effectively made up of a series of profiles. The profiles revolves around, and there's some time being spent with those profiles, effectively getting good control of them, looking at their curvature and understanding their curvature and how fast the flow is on that those curves. Okay, so I'm just going to hide that and show what really are the theoretical surfaces, the main blocked out surfaces. We've got our revolve. We've got an internal revolve here, which would be, this example, it's like a dial in a car. Yeah, it's like an automotive dial in a dashboard. And this could be an LCD or something, giving us a little bit of readout while we turn something, depending. This is the dial where our hand's going to grab it and we're going to rotate it around, turn it. And we're going to put a perforation on here. But we're also going to show you just a couple other ways that I haven't shown in class before, just how to add some surfaces. So if I hide this away just for now, just hide that one. And if I turn the layers on, I'm also going to show you how you can use the same script to make a diamond pattern. And you'll note on the diamond pattern that it varies in its height across from the front to the back, and it varies in its size. So from the back it's larger, the front it's smaller. The front it's actually higher, the back it's lower. And then I'll also show you how to do that with points, so how to make diamonds and how to treat those diamonds and get the surface to join correctly, particularly here where there's a curvature in the surface. And when we're creating diamonds, we're actually creating them as they're not curved diamonds, they're planar diamonds. So we need to do a few things to get that to be right. And first of all, we're just going to look at hole perforation. So here's the hole perforation and how we can remove the perforation around where a detail might want to go, how we can do that. So without further ado, let's get modeling. Alright, so here is our script. And this is the same script that we gave out in class. So feel free to download it to follow along. We've got our underlying surface, so here it is here. And you'll note that mine's blue at the moment. That's because here in Documents, you can adjust the color. Normally it is a red color, and it's adjusted down like that. But you can adjust the color. Then what we've done is we've effectively used construct domain to limit our surface. The construct domain limits the surface. And then we put that domain into our IsoTrim. And what I've got here is a limited surface. And I can adjust these sliders to adjust this in and out. So if I just pull this one, you'll see that the start and the back adjust like like that. And same at the front, I can adjust the front. And I can limit the area that I want my diamonds to go, or my circle pattern, or the knurling, you know, the rectangles on my pattern. Okay. Then what we've done is we've taken a diamond panel. And the reason why I want to be able to show you this is because if you want to model something like this diamond pattern here, you have to use diamonds. You can't. In LunchBox, we also showed you that you can avoid having to work with this bit of the script here by using a hexagon cell instead. And hexagon cell, if you don't need to join the ends of the diamonds together correctly, you can just use a hexagon cell and you can get a diamond-like alternating pattern through that. But here we're going to use diamonds, and this is the reason why we would use diamonds. Let's hide that away. And the critical thing about the diamonds is if we come around here, we can actually see hard to see here, but we've got the edge of our seam on the diamonds. If I come back to the IsoTrim, and I preview it, and I turn my preview off there, it's actually quite hard to see. But we've got our join, the seam of our surface in here. There it is there, the seam line. Okay. Okay, I just added a Brep edge in here, and that makes it a lot easier to see the seam. There it is. So I'll preview that off, and I'm going to leave that Brep edge on here, and we might just add a color to it, just so that it makes it a lot clearer. Color swatch, and get a preview and take these edges. Now I can preview that off, and the seam line, there it is there. Let's put both of those in by holding shift. Alright, so we've got our diamonds. And our diamond sections are running around our pattern. And at the moment it's 100 running in the U and 10 in the V. And we can adjust those. And here's the number I used for my previous model. If you've got that script, it was 192 by 12. Now the important thing to note is that with the diamonds, if we just take a surface, and we plug our diamonds in, you'll note here that the surfaces for the diamonds are all in white. And then we've got these 4 triangles here. In fact, we'll join all of them running along the seam, but then we want to get the resulting 4 triangles here and join them into the rest. So the main problem that we have is that if we don't connect, all of these around, then we'll get center points appearing in here, and it won't work well for script. So the way that we look at this is that we take a division, so here B is 2, we divide 10 by 2, which is 5, and if we look along here we've got 1 set, 2, 3, 4, 5, 6. So we divide our number here and we get a series count, and the series count that we want is x plus 1 as an expression, and then that gives us 6, and it gives us 6 values. So the division gives us 5, and it's just a number, but the series gives us 0, 1, 2, 3, 4, 5. And we can use that series to list the items in the script. So if I click here and I preview this, I'm just going to hide that away, and I'm going to hide that one away. So I can list the first set, the series lets me list the first 6 in the surface. So the surface runs this way, it runs counterclockwise, which makes sense because our normal, we had the color on the outside, and because we have back face color added, if our circle went in a clockwise direction, it would have been pink. We've also got list item here, and you'll note that under L, I've reversed the list item. And when I reverse the list item, it takes the last 6. So we've got the first 6, and we've got the last 6 here. Then what we're doing is we are joining them together. And by joining them together, we effectively get 1, 2, 3, 4 diamonds and 2 triangles. So we need to cull our list because we have 6 open breps, but those 6 open breps are 2 triangles, 1 at either end, and 4 diamonds in between. So what we need to do is we need to take a cull index, and we just need to set it to 0 so that it culls the first set out. So if I preview this off and preview this on, it culls the first one out here, and then I have copied it and simply reversed the list so that it culls the last one out. If I preview that and I turn that preview off, now I've culled the first and the last triangle off, and I only have diamonds. So what I can now do is take the diamonds from here, the diamond panels, and the diamond panels that we've got here, and put them together and find all of their centers. And by finding their centers, I've got a perfectly even pattern running around with my diamonds. And the good thing is, if we preview these diamonds, if I adjust my U division, I make it larger or I make it smaller, you'll note that the corresponding diamonds all cull out correctly, and we've got a functional script. The important thing to note here is that the slider is an even number slider, and that allows everything to match up correctly. And here I would believe that this is also an even number slider. If we made this an odd number slider, you'll note that our triangles don't match up correctly. So we always need to remember, when do we need to have even numbers and odd numbers feeding into something like our diamond panels here. Okay. So that's really the first part of the design done, and we can use this tool here, Brep closest point, and we could find from the centers and the Brep, we can find where the points are on the surface, we can get their point out, we can get the normal out, and we could use a circle CNR, so the centroid, the normal, and the radius, and we could control how our circle sits along our surface so that it aligns with the surface itself. And we can see that if we preview these circles. If I detach this at the moment, I'm just going to detach that and preview that. You can see how our circles all perfectly line up to our surface. Okay. Problem with this is that, well, there's twofold what we're going to do. The first one is that we've got a port that is coming into this design. Okay, so what we need to do is here we are scaling with remapping. We're scaling the diameters of the given circles. And what I've done here is I've taken my ISO surface. If we come back here, we can see from the ISO surface through this relay and then along. I've got the Brep and I'm finding the edges of the Brep. And I am effectively taking this outside edge of the Brep, and I'm going to scale everything and measure all the centers of these centroids back to this edge and find all their distances. Then what I've done is I've found all of those distances. So curve closest point gives us distances. I've got 441 distances. And I can adjust those differences by constructing a domain. So my smallest circle will be 0.5 in radius, and my largest circle will be 1.5 in radius. And I can connect those remapped numbers into R for the circle. And you can see here that at the front, the circles are 1 millimeter and in diameter, and at the back they're 3 millimeters in diameter. But the important thing here is that you'll note that there's this area, and if I turn my curves on, you'll see that I've got this USB-C port kind of design in the back here. And we don't want our circles cutting into the port, so we need to cull these points out of our script so that we have some material around here for the USB-C port to work. Effectively, that's what this script is doing here. So if we have a look over on the area, we've got 451 points. And then when we look over here, after we've culled the pattern, we've got 441 points. So we've removed some. And the way that we do that is we're using a Brep. We're using a 3D volume. And we're basically finding all the points that sit inside this volume. So I've flattened my tree. The data structure here is on trees, so I've flattened it all. I've got this point in Brep. I've got my Brep referenced in here. And what I'm doing is coming out of points in Brep are true-false statements. What's in the Brep is true and what's outside the Brep is false. So we can use a cull pattern, but I need to invert my cull pattern, because if we don't invert the cull pattern, we basically get where the Brep is, the points that are inside the Brep. So we need to reverse that. So we just click invert. So inverting makes a false boolean a true statement. So here everything that's coming out as true is now false, and vice versa. And so we've trimmed these points out here using this Brep. And we can move the Brep around, and this will dynamically adjust as we go. We can scale the Brep, and everything will work as planned. So I've got my curve closest point, I've got my remap numbers, gives me my circle diameters, I've got my Brep closest point, which effectively gives me the points location on the Brep and the normals. So the normals perpendicular to the surface itself. Okay, so what I'm doing here is I've got my circles, preview that off, and I'm actually moving them. And I've moved them down inside my design. And I've made sure that they don't cross over or that they don't intersect when I've moved them. And I've just used the number slider and the amplitude. So I've taken the normal, plugged it into the vector, and I've adjusted my amplitude here to negative 3.7. And then I have extruded extruded these edges and made surfaces. And you can see here that I've extruded them up a distance using the same vector and amplitude. And I effectively have extruded those up, which then when I cap the holes, and you can see I've got a data dam here, just because this takes some time. If my data dam is set for 1 second, we could put it to half of that. And now I get my pins that I can Boolean union out of my solid. And effectively, I will end up with a design like this. So if I turn the preview off, I get that. So it's pretty straightforward, and that's what we did in class. So I'm just going to hide, actually I'm not going to hide the script, I am going to disable the script. I'm going to hide that. I'm going to come to this script here, and I'm going to enable it. I won't enable the end at this time. Now what we can see with this script is that everything's the same. The diamonds, the IsoTrim, the connecting the diamonds, all of that's the same. And what that gets us is it gets our centers around our surface, and it gives us, if I preview it, a series of curves, the diamond curves on our surface. But you'll note here that the diamonds are made up of planar lines. Yeah? And if we made this just using the curve, we wouldn't be able to join the surface of the back onto the diamonds here. So what we have to do is we have to use pull curves. So we're taking the exact same data that's coming to the curve here, and we're adding pull curves. So effectively we're getting diamonds, and four joined diamonds, and we're bringing them both in to both the curve here and the curve here. And if I preview this on, and I zoom in, you'll note that these curves in white vary to the original curves because I pulled these curves up onto my surface. And this is really important because now when we split and trim and join our surfaces back up, that they'll actually go together again and become one surface. If you don't do that, you'll get three surfaces and they won't join. Okay, there's nothing you can do about it. They're almost impossible to join. So the script effectively is exactly the same here. We've got a Brep closest point, and we have our curve closest point at the front, and we're measuring the distances to all of the diamonds, and we're adjusting our diamonds here. And what you will note is that I've disconnected my construct domain. Okay, it's not connected at all. I'll just move it down here. And I've put a graph mapper in instead. And I've pulled the edge of the graph mapper up so that it starts at a higher value. If I pull that down to the bottom at 0, it would, the scale, if I preview it, the scale would give an error. It would be red because you can't have a zero sized geometry. I'm just going to show my original surface, and then you can see how everything is flowing onto that surface there. Okay, now I've taken my numbers, I've got my remap graph, and I can adjust that, and I get a nice blend of diamonds running here. And I scale them down. And if I adjust this, if I pull this curve out, my script is going to run slow because I need to disable other things, but you can see how my script is adjusting. Okay, so we probably need a data dam in somewhere after the scale, just to allow us to scale quickly if we want to in the script, and then allow the data to flow on. So in order to build the diamonds, what I've done is I've offset my scaled diamond. So I've scaled the outside, I've scaled it in, and I've lifted it up. I've moved it using the normal direction. I've moved it up an amount. And the front diamonds lift higher and the back diamonds lift less. Yeah, there's less height in them. And the way that I've done that is effectively I just copied the remap numbers from below, from here. I copied it all. And I plugged it into the amplitude, and now I'm adjusting the amplitude for the diamond. So I can adjust the domain start and the domain end, and it will lift these ones higher or lower at the start, and it will lift these higher or lower at the end, and everything else in between will be a value between those two numbers. So it's a value between 0.32 and 0.6. And that allows us to scale the heights up and down. And that's our move. Once we've done that, I'm going to preview this off. What I'm doing here is I'm building an edge surface, a four-sided edge surface. The way that we can do that, if I preview it on, there you can see that surface, edge surface. The way we can do it is we can get the Brep edges, so we can take these geometries, the little diamonds, and we can use Brep edges to find the outside, the naked list, the naked edges. And we can plug them into a list item. And with a list item, what we can do is, normally it looks like this. And if we plug these Brep edges in, we'll only get the first items of every line coming out. And you can see it here. There's the first item of this diamond. What we can do is zoom in and we get this plus, and if we click it, we can see that we're getting edge 2. And note the way that it's flowing. It's in a counterclockwise. Now we can get edge 3, and then we can get edge 4. So now we're listing out the 4 edges, edge 0, 1, 2, and 3. And then we can correspondingly plug this into the surface edges A, B, C, and D. And what I discovered was when I baked this out onto a layer, so let's just create a new layer and make it active. When I baked this out, so bake, put it to that layer and group it, what I discovered is that my faces were actually going in the wrong direction. So their normal, the reverse of the normal, was showing up. So I used this tool here, flip. So we flip the normals on the surface. Preview that off. If I select these and I delete them, and then I bake my flipped surfaces, you'll note now that they're facing the correct direction. Okay. Also, what I've done is I've taken the curved outside edges and I've taken the scaled edges, preview that on, the scaled edges, and I've lofted a surface between those. So actually I didn't choose the scale, sorry, I chose the ones that I moved. Here, the moved ones. So I've got the curved diamonds here that goes into D2, and I've got the offset diamond here that goes into D1. I've merged them. And you'll note in this data, what I've done is I've actually grafted the data. So I've used graft. That's so that I can get both of the data structures to match. So I've grafted them. Normally we talk about flattening, flattening, flattening. Well, here we're actually grafting data to get it to match up. And if you took a, where is it, under params, you looked at the param viewer and you plugged the data that's coming in, plug these lines into that, you'll note how the data structure is working. And now what I've done is I've lofted that. So if I preview it, you can see here that I've got my diamond loft. This is like the knurl on our surface. Whoops. You can see it here. And then above that, we have our surface that fills that in. And you can note that I'm flattening my data and I'm using Brep join. So if I preview that off and preview this on, you'll see that I've got my joined, if I hover above it, on the B, one locally defined open B rep. Okay. So that's cool, we've got our diamond pattern. And if we bake that, and turn that preview off, you can see here that we've got our diamonds. Yeah, the knurled pattern that's variable. Higher at the front, lower at the back, larger at the back, smaller at the front. Okay. That's really nice. So we've got that. What we need to do is I've taken my original surface, okay, not the IsoTrim surface, but my original surface. And I've taken this Brep and I've found its edge and I've joined all the edges. So if I preview that, I've found outside edge of the knurl pattern. And I'm going to split my original surface. So I'm using this surface split. And when I split that, if I preview it, what I get is I get three surfaces, effectively if we come inside. I get the back half, I get the middle where the knurl is, and I get the front half. And what I want to do is I want to actually omit the middle piece where the diamond, where the knurl is, the diamond knurl is. So I'm again picking up the rear and the front surfaces, and I'm taking my knurled surface and these front and back surfaces and I'm merging them together. So I can actually get rid of D4. Merging them together. I'm flattening that data and I'm joining it. So I don't actually need that flatten there because I've already flattened it. And what you'll notice is from here I've got three open breps. They're actually two trimmed surfaces and an open brep. And then when I join it, I've got one open brep. And that's really cool. So we get our mesh file. So if I hide, if I delete that, and hide those surfaces, in effect what I get is this diamond pattern here. I'll just come out and I'll hide everything in the script, preview off. And you can see here that we've got this one surface. I've got it locked. Here it is here. All right, so what we can do, actually that's the diamond one. What we can do, let's turn on the correct one. Okay, here it is here. So what we can do is we can soften this off. And the way to soften it off is we can actually convert our mesh. Let's just preview, enable this. It'll take a second. So what we do is taking our Brep and we're converting the Brep to a mesh. Now here, this component is from a plugin called Flexibility, and you can use the package manager to download Flexibility and install that directly into Grasshopper. So we're turning our Brep into a mesh. We can adjust the density and the minimum lengths. We use a standard join mesh. The rebuild mesh, if required, is from Puffish. And I've used this plugin here from Weaverbird, and it's called a Cutmelt-Clark subdivision. And if I preview that on, I'll hide this. What you'll see is we get this really nice soft pattern. And if we come to mesh and we show the mesh edges, you can see that we've subdivided those diamonds down into a soft mesh. And you can only go to 3 levels of subdivision in here. So I copied it again and I added another level of subdivision. And you can see here I've got quite a dense mesh running. But I could 3D print that now and I'd have a really smooth, sort of dimpled mesh. So I just preview that on, preview this one off, and delete that. You can see that we've got this high resolution mesh. And we could construct that, join it with other meshes, turn our other surfaces into meshes, and join it all together and 3D print the outcome. So there we have it. I've shown you how you can use the script from last week to make holes perforated into a part, or how to take those diamonds originally and create some offsets, move some data, scale it, and create a really nice knurl pattern here that allows you to create a dial effectively for a car. And we can have a look at the surfaces here and see how that all flows. I hope that's of help and that you are able to go through the sections of this video to get your assignment done. Alright, thanks everyone.